go ahead and let's identify some different things when it comes to this rational equation here. We want to identify horizontal asymptote, vertical asymptote, x-intercept, y-intercept, and domain, all of those things. Okay, so first thing you want to remember is when I'm looking to find a horizontal asymptote, okay, what I'm going to do is I'm going to look at the exponents for each of my the numerator and the denominator. Now my lead exponent here is actually a 1, x to the first power, and the exponent in the denominator that's in the lead is a 3. So I ask myself, okay, the numerator exponent is smaller than the denominator. If that's the case, there's a certain circumstance. If those are the same, there's a different circumstance. If the numerator is larger than the denominator, there's yet a different circumstance. There's 3 different options here. Okay? When the exponent, the lead exponent of the numerator, also known as the degree, is smaller than the denominator, which is the case here, then we know that our horizontal asymptote is going to be at y equals 0. Okay? If those exponents were the same, then we would use the lead coefficients as our basically the fraction that would be our asymptote. But in this case, because they're not the exponents are not the same, then we don't. Okay. When it comes to vertical asymptotes, the best way to find a vertical asymptote or multiple vertical asymptotes is to take the denominator, set it equal to 0, and solve it. Well, first things first, if I look at this denominator, I can factor out an x, because x is a factor of all 3 of those different parts. So then this becomes x squared minus 1x minus 2. And I'm setting this equal to 0. I'm solving it because that will give me my vertical asymptotes. Okay, I'm now going to factor what's inside the parentheses. So I'm looking for 2 numbers that add to give me -1, multiply to give me -2. Well, in this case, that would be a -2 and a +1. Okay, and I'm looking to solve this. So when the whole left side is equal to 0, the question is, what value here would make the whole thing 0? Well, if x was 0, then I would have 0 times something, so there's 1 of them. Here, if x was 2, then that part would be 0, which would make the whole left side 0 because they're all being multiplied together. And then here my solution would be -1. So in this case, I actually have 3 different zeros, 3 different vertical asymptotes. Okay? For an x-intercept, okay, to find my x-intercept, well, an x-intercept is when the y value equals 0. Okay, and in this case, if you think about where my horizontal asymptote is, which we already decided that I had a horizontal asymptote at y equals 0. Well, that means that I'm not going to have this cross, the graph itself is not going to cross over. So in this case, my x-intercepts are going to be none, because I'm not going to cross the x-axis. On the other hand, my y-intercepts, oops, sorry about that, is whenever the x is equal to 0. Well, I already have this thing put in my graphing calculator. I'll go to the y equals for you so you can see what it looks like. So this is what it looked like when I put it into my y equals. And now I'm going to go to the table, second table, and I'm looking for the y value when my x is equal to 0. Well, that's an error. That means that there isn't one. Okay. I also, while I'm at it, I want to kind of look for, okay, do I have any y values that are 0? Because that would be my x-intercept. Well, as anticipated, there isn't one. Okay. So, whoops. undo that. So going back here, I now note that my y-intercept is also none, because when I looked in my calculator at the table, I had an error. So let's go ahead and let's graph our vertical asymptotes here. I'm going to throw vertical asymptote at 0. I'm going to throw another one at 2, and yet another one at -1. Okay? These are all vertical asymptotes. Okay? I'm going to go back to my calculator here and just look at the graph and get an idea for, okay, what's this look like? It looks like this, and in this case I can actually, when I look at this graph, I see a couple things. The first thing that I see is that it almost looks like I don't have an asymptote at -1. Okay? Although when I solved it, I got an exception at -1. So here's what that leads us to believe. If we go back to this, I actually need to take this guy here and cut it, because when I look at the graph from the calculator, it looks like, let me go back here, and right about here, where the -1 is on my graph, it looks like I do have a graph. Kind of goes along here and goes up like this. What it means, though, is that at -1, right in here, we have a hole. Okay, so somewhere on that graph, on the purple line, there's just an exception. It's not necessarily an asymptote, but there's just a hole in the graph. So then to fill in the rest of this, it looks like down in this part, my graph, now I'm drawing this with my finger, so I apologize for how not consistent it is, but that's just kind of the way it goes, I guess. And then up here, I have a graph that looks like this. Okay, so now the last thing here that they asked me for was my domain. Okay, and in this case, my graph exists from -infinity all the way up till I get to -1, and then I have a hole in the graph. And then it starts up again from -1 up to 0, approaches 0 but doesn't touch 0. And then it goes from 0 up to -1, I'm sorry, up to 2, that's +2. Goes from 0 to 2, and then it runs into another wall, and then it goes from 2 up to infinity. So there's a lot going on there. A lot going on with that. Okay, my next problem looks like this. I went ahead and I put this in the calculator. If you need to pause, take a minute to do so, you can. As you put it in, just make sure that you have a -1 that is under the radical, and then you have a -1 that is outside of the radical. Okay, and you make sure of that by using parentheses. So you have 3 times all that. When I go to my graph, it looks something like this. So I can see that right to the point x equals 1, or a little bit past that and a little below that, that's where my first point starts. That point is an important point because that's going to help me identify real quickly my domain and my range. My domain are my x values, my range are my y values. So I need to know what that last point is. Now as far as sketching this goes, if I go to my calculator and I go to the table, okay, I have some points here that I can use. I can use the point 1, -1. I can use 2, 2, so on and so forth. So to the right 1, down 1, to the right, what was that, 2, 2? Yeah. To the right 2, up 2, right about there. I can go 5, 5, 10, 8. So to the right 5, up 5, to the right 10, up 8. So this thing looks something like this. Put an arrow at the end. See if I can just move that down a little bit to actually fit. Okay. Now the big question is for my domain and range, because as I said, if you look at the actual graph and look where that point actually starts, I don't think the point 1, -1 is actually going to work. I'm actually kind of surprised it shows up on the table. So I'm going to go to my trace feature that's to the left of graph. And your little scroller thing there, it shows up as an X on my screen. You may have to kind of move it left and right for it to show up, but the last point that I get is at 1 and negative, 1.06 and negative 0.26. So 1.06 and negative 0.26. Okay, so if I'm graphing that as my last point, that's right about there. And that point is important for me just for the sake of my domain and range. Okay, my domain being my x values. Well, my x value is 1.06, and I'm going to the right. So my domain is going to be 1.06 up to infinity. My range, on the other hand, are my y values. Negative 0.26. Negative 0.26, once again, up to infinity because it's going up.